Well, hello and good afternoon, everyone. My name is Olivia Wan, and today I'll be sharing an overview of my capstone project, which focused on furthering equitable nature-based coastal adaptation in California. California's coasts are home to an array of unique habitats that are emblematic of the state, such as bluffs, sandy beaches, coastal forests, wetlands, and marshes. These ecosystems support biodiversity, economic activity, and the many diverse and distinct communities who call the state and its coasts home. Like many other coastal regions, though, the complex socio-ecological systems of California's coasts are greatly threatened by climate change-related sea level rise, coastal erosion, and flooding. The graphic here shows projections of how extensive the flood risk from sea level rise will be in the San Francisco Bay region during 100-year storm events. Current statewide projections anticipate flooding and erosion that will threaten core infrastructure, human communities, and coastal ecosystems. The images here on the right show inundation during present-day king tides, the highest of high tides, which offers us a glimpse of the future we can expect with sea level rise. The impacts, of course, from additive events like storm surge will result in even more severe impacts. The stakes and urgency of these coastal issues cannot be understated. This succession of photos of Gleason Beach on the Sonoma coast shows how quickly devastating changes to the state's coastlines may be realized with potentially catastrophic consequences. Thankfully, there are coastal adaptation approaches to proactively mitigate and respond to these climate impacts. The graphic here shows some of the many approaches used across the state to adapt shorelines to sea level rise, including hard protection or gray solutions such as seawalls and concrete armoring, softer nature-based solutions such as coastal restoration and living shorelines, and adapting infrastructure or even moving it away or retreating it from the shoreline. Traditionally, shoreline management has employed gray solutions. Increasingly, though, it is understood that these projects can be maladaptive. They can have limited project lifetimes, negative ecological impacts, and can even displace flooding risk to adjacent areas. Nature-based coastal adaptation approaches, on the other hand, seek to address shoreline change and vulnerabilities through the preservation, restoration, or enhancement of biodiversity, habitat, and other environmental processes. Thanks to historic public investment coming from 2 federal laws for building climate resilience, there is growing political momentum and dollars to move fast and scale up multi-benefit nature-based adaptation in coastal California. However, any current and planned shoreline adaptation takes place in a landscape with a complex social history of injustice that has previously guided where investment promoting resilience goes. As an example, this is a map of San Francisco showing neighborhood redlining. The term redlining comes from government home ownership and lending programs from the 1930s that created color-coded maps to determine the investment risk of different neighborhoods. The designation of high investment risk, though, was based on the racist notion that the presence of Black residents meant property values would decline. Redlining occurred in cities across the state, and its legacies manifest today through continued underinvestment and economic disparities in previously redlined areas. So as we consider this urgent, critical, and historic moment of investment in shoreline resilience, we also must consider how the investment or lack thereof of different kinds of projects or approaches may reflect these past or present injustices. This gets us to the concept of social equity, which is generally concerned with fairness and justice in how people are treated or public policies are formulated and implemented. Distributive equity, specifically, which is the concept that guides the work that I'll be sharing today, refers to the level of fairness in the distribution of benefits and burdens between different groups. I believe that in order to coordinate any equitable path forward, it is critical that we first understand existing distributions and how these may reflect inequity and injustice. In plain terms, through understanding where we are and how we got here, we can better understand what needs to change going forward. And as these photos from recent headlines show, indeed, inequity is already shaping efforts to adapt to sea level rise, flooding, and other climate hazards. we're seeing a dynamic in which project placement or investment is going to the most privileged while the most vulnerable are left at greater risk. This underscores the importance of incorporating equity and justice into policy, as well as planning processes that determine what kinds of projects will be done, where they will and will not be done, and who will benefit or be adversely impacted in the process and implementation. So my capstone consisted of work on two related but distinct projects, which allowed me to address the intersections of nature-based coastal adaptation and equity at multiple spatial scales with nonprofit and government partners. The first prong of my capstone involved working with the Nature Conservancy California on their statewide policy guidance for sea level rise informed conservation planning. The second involved research conducted in collaboration with the San Francisco Bay National Estuarine Research Reserve and the NOAA Office of Coastal Management through the NOAA Margaret A. Davidson Graduate Fellowship. My work with the Nature Conservancy built upon the organization's 2018 publication, Conserving California's Coastal Habitat, A Legacy and a Future with Sea Level Rise, which provided comprehensive spatial assessments of coastal habitat extent and vulnerability to 5 feet of sea level rise. An example map from the report is shown here on the right. The report also provided 6 strategies to conserve, restore, and enhance the area of coastal habitats in the face of sea level rise and other stressors. The coastal resilience team at the Nature Conservancy is now in the process of developing in-depth roadmaps for 2 of these strategies to help the state meet its ambitious climate neutrality and habitat preservation goals. The first, conservation of areas projected to become habitat with rising sea levels or potential future habitat. And the second, the strategic managed retreat of infrastructure. So as sea levels inevitably rise, coastal habitats really have only one direction to go. With space and a path, theoretically, they can migrate landward or vertically as shown here. But if these areas are developed, there won't be anywhere for the habitat to go and it will drown. The Nature Conservancy defines these minimally developed areas that are not currently habitat, but are projected to become habitat with sea level rise as potential future habitat. Statewide, there are over 55,000 acres of potential future habitat that could mitigate 61% of the expected losses of coastal habitat to 5 feet of sea level rise. In highly developed areas, the built environment is also vulnerable to sea level rise. And as we begin to strategically retreat this infrastructure, there's also an opportunity to restore coastal habitat area as well as the protective ecological processes that enhance coastal resilience to hazards. And again, these 2 strategies will be essential for meeting the state's ambitious goals for protecting coastal lands from development, as well as using natural lands to mitigate carbon emissions. My capstone work sought to incorporate environmental justice and equity considerations into the development of these strategies. To start, I conducted a review of academic literature and California policy reports on the topics of sea level rise, climate change adaptation, conservation, managed retreat, social equity, and environmental justice. From there, I developed a conceptual framework to look at the spatial distribution of indicators for coastal benefits and burdens along the coast. I looked at how vulnerable these indicators are to sea level rise and how proximate they are to disadvantaged communities as designated by California EnviroScreen. And finally, from the literature review and spatial analysis findings, I developed recommendations for conservation organizations like the Nature Conservancy to promote land investment that meets conservation goals, redresses existing inequities, and moves the state towards a more just and resilient future. So for spatial indicators, I looked at the coastal benefits of access points and carbon storage, and the coastal burdens of drinking water contaminants and impaired water bodies. This work demonstrated that if conservation planning does not meaningfully incorporate environmental justice, sea level rise will likely exacerbate existing statewide inequities. The following recommendations aim to center the needs and voices of communities by including broader goals in project planning, such as the improvement of access to the coast or remediation of pollution burden, ensuring that communities will benefit from project activities in the long run through understanding site-specific social vulnerabilities and working in collaboration with communities to identify approaches to minimize displacement risk and best serve stated needs, and supporting the repatriation of land to and in partnership with California's tribal communities. The second part of my capstone involved research at the regional scale of the San Francisco Bay Area, conducted through the NOAA Margaret A. Davidson Graduate Fellowship, an opportunity for grad students to conduct collaborative research at one of the 30 National Estuarine Research Reserves. As a fellow at the San Francisco Bay Reserve and the NOAA Office of Coastal Management, my project aims to evaluate how previous shoreline adaptation effort has been distributed across the diverse shorelines of the San Francisco Bay to date through an environmental justice lens. By critically considering and understanding the drivers of where shoreline adaptation has happened and why, we can develop policy interventions that promote more just adaptation across the region. So for the first phase of my fellowship, I looked specifically at the distribution of gray versus nature-based shoreline adaptation projects. Specifically, I aim to evaluate the relationship between this typology and the social and biophysical context of a project's location. This analysis aims to get at the larger question, what do patterns of shoreline adaptation say about differential patterns of community resilience to sea level rise? What does this say about who gets to adapt, who is adapted, and the specific kinds of shoreline adaptation a given site or community ends up with? So as a proxy for projects, I analyzed a point data set of permits issued by the San Francisco Bay Conservation and Development Commission, BCDC for short. BCDC was established in 1965 and is the regulatory entity that permits any project touching the bay or its shores. They are also a major actor working to coordinate a regional strategy to adapt shorelines to rising seas. I started with 1,126 permits for shoreline adaptation projects from 1965 to 2022 and coded for whether each permitted project employed a gray or a nature-based approach. I then spatially joined 192 of these points with site social and biophysical vulnerability data to build a random forest model to assess which variables are most important for predicting project type. This figure here depicts preliminary results from the random forest model, showing the most important site variables for predicting whether a given permit was for a gray or nature-based project. As you can see, the best predictors are the year the permit was issued, followed by community characteristics, specifically the percentage of the population that's white, linguistically isolated, and living below the poverty level. The biophysical variables in the blue boxes were less important for the model's predictions. And this is interesting because following the issued year, it suggests that the relative whiteness, English proficiency, and income of a community better predicts what kind of project you're ending up with than biophysical site characteristics or relative sea level rise risk. In the next year of my fellowship, I look forward to refining this model and further exploring drivers of nature-based adaptation through the development of case studies of specific projects in the region. Beyond this ongoing research, the Margaret A. Davidson Fellowship has also provided an array of amazing opportunities for professional development and applied learning. I participated on a panel for the nation's coastal managers in Washington, D.C. I flew to Bergen, Norway for an academic conference, and I conducted site visits where I learned about nature-based adaptation in action in California and Washington State. On top of this, I've gained another cohort family of fellows and a broad network of mentors that I've already learned so much from. As far as the next steps after coastal science and policy, I'll be joining the San Francisco Estuary Partnership's Social Science Advisory Team to improve the integration of social science, including equity and socioeconomic considerations, into the next update of the San Francisco Estuary Blueprint, a regional planning document. I'll also be starting a PhD this fall at UC Berkeley in the Landscape Architecture and Environmental Planning program, where I will continue studying sea level rise adaptation through an environmental justice lens. I want to close by thanking my wonderful capstone project team from CSP, my incredible advisor, Katie Cito, Anne and Sarah, the team at the Nature Conservancy, including Walter Heedy and Alyssa Mann, and my mentor team at NOAA, Melis Akhter, Amy Good, Matt Ferner, and John Razum. I also want to extend my deepest gratitude to the fellow members of the 2023 cohort and the Katie Cito Research Group. There is truly no group of people I would have rather gone through this experience with. So thank you everyone very much for your time, and I look forward to answering any and all questions.